Morning everyone. Today is our thesis presentation one. Our topic is waste.
Can you raise your voice a little bit, please?
First, let me introduce you to my group. Muhammad, Ahmad, Marwan, and Ahmed. First, we'll go quickly through the outline. We have the background project overview, scope of work and objectives, experimental work and methodology, expected outcome and expected challenges, and the target. First, we'll start with the definition of e-waste. What is e-waste? E-waste, for short, or waste electrical and electronic equipment, is the term used to describe the old end-of-life appliances that has been disposed by their original users. The topic is widely of a wide concern through the whole world because it has been the market of the electronic equipment has been the market of the electronic equipment is increasing rapidly through the whole world, and it's increasing because of it. The sources of e-waste are too many. We have the IT and telecom equipment, household appliances, lighting equipment, electric and electronic tools, toys and sports equipment, medical devices, and monitoring and control instruments. Here in the pie chart, we can see it describes the number of each device of them through statistics that has been made in 2009 for each device. We have the number of it. And for the current situation in the whole world, we can see from the charts that the e-waste is increasing through the years, while for the other colors we see is the number, is the percentage of the e-waste that is recycled through the world. Of course, we can see that it's not as increasing as the number of e-waste. And for now we can see through the other chart that in 2013 the number of e-waste has reached about approximately 50 million tons, and is going to increase more through 2014 and 2015. Now, Muhammad will go through the current situation.
For the situation in Egypt, we were not able to find the statistics were not available for the quantities themselves for the e-waste, and in general, all statistics we found were just estimates, as it's not that easy to count quantify the e-waste. As for where the waste goes, there are two main places where the waste is dumped, or landfills, in Manchate North and Saqqara. And we were able to find two recycling companies called Recyclovicchia and eCycle. These two companies aim to manage and dispose the waste in efficient ways. To start off, they didn't have the adequate facilities to recycle and dispose the waste, so they collected the waste from landfills and from individuals, and then sold it to China, where the waste were disposed. Now they grew, and they built their own facilities, and they're now able to locally recycle and dispose the waste. There are four main methods of disposal. To start off, the landfills. These are pieces of land where the waste is dumped. The main problem with this method is that harmful materials or toxic and hazardous materials from the waste can leak into the ground and soil and can contaminate the groundwater. The second method is incineration. This is a process where the waste is burned. This releases also toxic and hazardous substances such as lead, and this harms the environment and produces negative effects. The third method is the reuse. If the components of the device itself or the e-waste is fit to use again, it's used as is, or is used as input in another place. The final method, which is the most optimal, is recycling. However, this is the most expensive. This is basically where the device is dismantled and separated into its components. The good components are sold, and the hazardous or toxic components are disposed of correctly through special factories. this is a summary for the different biochemical components in e-waste and their health and environmental effects.
So our objective is mainly to examine the properties of Portland cement concrete while partially replacing coarse aggregates with electronic waste. Our scope is to investigate the extent and types of e-waste in Egypt, and to investigate properties of concrete made with e-waste, and to determine appropriate dosage ranges of e-waste replacement. So we're planning to have 6 different mixes, each with a different percentage of e-waste replacement, ranging from 0% to 25%. And for each mix, we're going to do 3 stages of concrete test: fresh concrete, hardened concrete, and long-term concrete test.
For the fresh concrete test, we have actually 3 tests. The first one is the slump test to determine the workability. The second one is the air content and unit weight, and the third one is the temperature. For the hardened concrete test, we have the 3 tests as well. First one is the compressive strength, and we'll test for 7 and 28 days. And if possible, according to, if we have time, we're going to test for 56 days or more than 28 days. And we'll prepare these samples. And for the second test, the flexure strength test, we'll test for 7 and 28 days. And for our third test is the stress strain test. We are doing this test to see whether using the replacement of e-waste has enhanced the brittleness or ductility of the concrete. And for the long-term tests, we have 2 tests. The first one is the rapid chloride permeability. We do this test not only to see whether we do this test to see not to see only how permeable the concrete is, but also to see whether the e-waste replacing the partially of aggregates has affected the electric conductivity. And the third and the second test is we'll expose the concrete to elevated temperature. And here are the STMs that we will abide with. And here are some machines. The one on the top right is the compressive strength machine, and on the left is the flexure strength. And this one, in the blue one, for the air content and unit weight. And here is the one for the rapid chloride permeability test. And here is our mix design. And we'll leave the floor from my colleague Amber.
Now is our expected outcomes. Developing a sustainable management of e-waste, knowing the effects of e-waste on concrete, learning effective time management, and teamwork skills, interaction with the sustainable side of construction engineering, and taking a step forward to environmental friendly outcome. However, we may face some challenges, like allocation of e-waste, disassembly with electronic devices and equipment before crushing, mixing the concrete in a homogeneous way, consistent supply of e-waste and the limitation of quantities we need, limited also publications and references that can help us, time constraints and limited lab space, cost estimate, and health issues handling with these things. This is our tentative time schedule. We'll be working in issues simultaneously in order to be able to meet the time constraints. Our references.
Can I start with one question? The e-waste has a variety of materials. Could have plastic, could have the silicone board, could have wiring, could have so many things. Are you going to separate between this, or are you going to use it as it is, regardless what kind of material it is?
For crushing, we will have to separate them, and if we can find proportions to mix them, or we can use them.
So what's your criteria? What are you going to include? What are you going to exclude?
According to what we have. According to the majority of the materials we will take.
Not to the effect of it on the concrete or the harness of it to the concrete. It's just about by what's the majority of the material that you have, it's this what you use.
Yes.
Okay. My second question, when you said you're gonna have 10, 15, 20, 25% replacement of what? Of the fine aggregate, of the coarse aggregate, of the cement, replacement of what exactly? What are you gonna replace?
Replacing coarse aggregates by weight.
Replacement of coarse aggregate. So this is gonna be a replacement for the coarse aggregate. Okay, thank you. Dr. Imam.
You said by weight. Now, this material, most of it would be plastic. So when we talk about by weight, really, the volume corresponding to this, did you have an idea how much volume will be taken by 28% replaced?
Haven't gone through it yet.
Second,
Just a second. I think you know the answer for this question, and we discussed it yesterday at length.
Yes,
At length.
Yeah.
كلمة كتير فيها.
Yes, I know that's one of our challenges because we don't know exactly the specific gravity of these materials, and we will be working with our advisors to know the specific gravity so we could know the volume.
you need your advisors to know the specific.
No,
gravity.
because the materials are not consistent.
But
When you said you will be crushing, so you will crush it, grate it, what is really the end material that you really mix in your concrete? What is the size? I mean, do I expect to see a wire, for example, spot to your cube? So do you have an idea to what extent you will really get the material into?
According to the previous study, it was mainly and the biggest portion was plastic.
I don't mind. I mean, you can raise it until you see the size is 2 millimeters, 3 millimeters, or what? I mean, that's.
We'll try to get it as closer as possible to coarse aggregate. Coarse aggregate. Same size as coarse aggregate.
I have actually two recommendations, not a question. The first one is that you need to describe this e-waste regarding density, shape of the size, flackiness, and that stuff, so that we can apply your research afterward. I mean, you have to describe thoroughly for anyone who is going to read your work what kind of waste you mean and how did you produce it. I mean, the composition, the weight, and such stuff. And then maybe according to your, this is also a recommendation to be added to your thesis. If you'd like, according to your results, what kind of application we can use. I mean, we can use this e-waste according to the percentage. Can we use it in structural concrete or maybe other applications that you can recommend based on the properties would be useful in this case.
thank you. Dr. Moran, do you have any question?
No, thank you.
Any other question here? Dr. Najib?
Let's go back كده, and I want you to cheer up شوية. شكلكم مشدودين وخايفين unnecessarily. I expect you to speak at a little bit louder voice. I was having difficulty hearing you. Just one thing. Would you replace شوية aggregate and you put exactly the same weight amount of e-waste, or you're going to do something different?
So the replacement.
So you're going to put the exact same weight,
Yes.
okay? But you have to take into consideration what? What Dr. Imam talked to you about.
Specific gravity.
Okay,
It's not the
specific.
same.
So it's not the same. So you're aware early that you're dealing with a product that's not an aggregate in terms of its density, okay? Because you appeared as if you're hearing this for the first time. So that's one thing. Second thing, do you expect this concrete to be way stronger than conventional concrete or similar, or why are you doing this work to begin with?
For finding a solution for an environmental issue.
So you don't, because this question was asked, and I think we need to ask ourselves, you're not necessarily looking for a higher quality concrete, but definitely something that has to do with environment.
Yes, it's, the strength is out of our scope of work.
Actually, you're testing strength.
Yes, we're testing, but it's not the main issue regarding.
Okay, so you don't say it's out of the scope of the work. It's in the scope of the work, but it's not your main goal.
Yes.
Okay. Third, is you're testing a new, I think it was you who said, or somebody said, yeah, with the strength part. The third thing, what kind of different properties you may find a difference from conventional concrete? Now, we shouldn't be ahead of ourselves. Where would the difference take place?
Maybe because we're using electronic parts, it would be in the conductivity.
Twice. Maybe you have a different concrete
Conductivity.
electric conductivity?
Yes.
Yeah.
And, if we added, and maybe we'll see well the brittleness or the ductility is affected of the concrete,
بالواوي؟
and
واحدة كمان. ها؟ elevated temperature.
the elevated temperature عشان
Plastic inside, you're heating the concrete. Yes. Thank you.
Before I have a request from you, please. Before you take my computer and consider it electronic waste, erase all the data from the CD. I don't want my data to be trapped in the concrete. Okay, thank you.